All right, this is the key on calculations with heating curves. I'm going to explain the process for doing this and then go through all the examples, and hopefully by the end you should be pretty good at it. The first question here says how much heat is needed to go from 53 grams of ice at negative 25 degrees Celsius to water at 50 degrees Celsius. So the first thing you have to do is plot out your course here on this little graph that we've got. So we start out at negative 25. And then we heat it up to 0. It's a solid at this point, and so then we have to melt it. So we go along this route, and then now that we've melted it, it's liquid water at 0 degrees Celsius, and we need to heat it up to 50 degrees Celsius. So if you look there, you should notice there's 3 steps: heating up the solid, then melting the solid into a liquid, and then heating up the liquid. So that first step there, number 1, we've got ice, and we are taking it from negative 25 degrees Celsius to 0 degrees Celsius. All right, since we're changing temperature, you're going to use the MC delta T equation. Mass is 53.00. C for solid water, 2.060. Change in temperature is 25. All right, you multiply those together, you get 2,729.5 joules. Then step 2, that's the melting step. So for melting, we're going to say delta H equals M times heat of fusion. Okay, remember fusion is used whenever we're melting or freezing, whereas heat of vaporization is used when we are boiling or condensing something. So we multiply them here, 53.00 times 334, because that's the heat of fusion listed above. Then we get 17,702 joules. The next step, step number 3, we have another change here. What we're going to do here is change the temperature from, and it's liquid water, right? So liquid, and we're going to change the temperature from 0 degrees Celsius up to 50 degrees Celsius. All right, so we say Q equals MC delta T. M is 53.00. C for liquid water is 4.184. Change in temperature going from 0 to 50, so it is positive 50. Multiply those together, you get 11,087.6 joules. And then what we're going to do is add all of those up, and we get the total Q for all of this equals 31,519.1 joules. Moving on here to the second problem. This one says how much heat is needed to change 35.0 grams of water at 0 degrees Celsius to steam at 104 degrees Celsius. What if it had been ice at 0 degrees Celsius to steam? So first of all, the thing to notice here is we're starting at 0 degrees Celsius, but there's this entire line here that's at 0 degrees Celsius, and so you need to know where particularly we're starting. To do this one, you have to realize that we have a solid phase down here. This is the solid, and then we have a liquid here, and then we have a gas up here. So if we are starting out with liquid water, just normal water at 0 degrees Celsius, we are right here, starting at the liquid side of 0 degrees Celsius. So that's going to be where we start our line. We have this, we heat it up, and then we have to boil it, and then we heat it up another 4 degrees. So it's a 3-step problem. Step number 1, we have Q equals MC delta T. This is for liquid water. as I said, what we're doing here is we are going to be changing the temperature. So the mass, 35.0. C for liquid water, 4.184. Delta T is 100 degrees because we're going from 0 all the way up to 100. Multiply those all together. We get 14,644 joules. Step number 2, we're going to boil it all. So for this one, we know delta H equals mass times heat of vaporization, which equals 35.0 times 2,256. That is 78,960 joules. Third step, we're going to take that water. Now it's been boiled away, so now it's water vapor, steam. We're going to heat it up an additional 4 degrees. So we use Q equals MC delta T because we're changing the temperature. Mass is 35.0. Oops, 35.0. Now we're going to use the C for gaseous water, so it's 2.070. And then the change in temperature here is just 4 degrees, from 100 up to 104. So we multiply those. We get 289.8 joules. You add all those together. What we end up with is 93,893.8 joules. Now, the second part of this question, it says, what if it had been 0 degrees Celsius, ice at 0 degrees Celsius to steam? And so this is basically saying, like, what would happen if we had started out on the other side of this line here. And so if that had been the case, we'd have an extra step there at the beginning of this problem, an extra 4th step. And so we've got this sort of other step here. We'll call it step number 4, although really technically speaking, right, it goes here before the first step. What we have is delta H equals mass times heat of fusion, because what we're doing is we'd be melting the ice, equals 35.0 times 334. Multiply those out, you get 11,690 joules. Then if you add that to what we had before, so this is our original Q total here. Okay, if we add this next step on here, then we get a Q total $105,583.8 joules. All right, on to problem number 3. Problem number 3, we have steam at 200 degrees Celsius. It says it's cooled to ice at negative 100 degrees Celsius. So there's a couple things to notice here. The first thing is we're starting in steam form and we're cooling it. So this is the first time where we've been cooling. So what we do, start up here, 200 degrees Celsius, cool it down, then we condense it. Now it's liquid water. We're going to cool it down to 0 degrees Celsius, and then we'll freeze it, and then we're getting down to ice at negative 100 degrees Celsius. So to indicate that this is going in the negative direction, I do a little set of arrowheads here, and I say it's going down. And so our answer is going to end up being negative for each part here in the end, because each part here is going to be exothermic. So the first step, we've got steam at 200 degrees Celsius. And we're getting it to 100 degrees Celsius. And so that's going to be a Q equals mc delta T problem, Q equals mc delta T, which equals mass, in this case, 75.0. C for steam, 2.070. Change in temperature, 100 degrees. Went from 200 down to 100. And this is negative because it's gone down. All right, so you multiply those things together, we get negative 15,525 joules. Step number 2, we're condensing it from a gas into a liquid. Condensation is a exothermic process, so again, it's going to be negative. We've got delta H equals mass times heat of vaporization, which equals 75.0 times the heat of vaporization is 2256, but we're going to call it negative 2256 because, again, this is the condensing form. So it's in the negative direction. It's going to be exothermic. Multiply those together, we get negative 169,200 joules. Step 3, we've got water, and it is going 100 degrees Celsius down to 0 degrees Celsius. So we're going to use Q equals mc delta T, mass 75.0, C for liquid water 4.184, change in temperature 100 degrees, negative 100, going down from 100 down to 0. So multiplying all those things together, I get negative 31,380 joules. Then we're going to freeze it. So for that one, we're going to have delta H equals mass times heat of vaporization. Oops, heat of fusion here because it's freezing. Which equals 75.0 times and negative 334 because it's freezing. Multiply those together, we get negative 25,050 joules. And then one last step here, we've got ice, and we're going to be going from 0 degrees Celsius down to negative 100 degrees Celsius. Okay, so we're going to say Q equals mc delta T again. Mass still 75. C for ice is 2.060. Delta T is 100. We multiply all those together. We get negative 15,000. Oh, yeah, sorry, it's negative 100 again because it's going down in temperature. So we get negative 15,450 joules. All right, so that's all 5 steps. We look at all those numbers, we add them together, we get Q total equaling negative 256,605 joules. Okay, that one was pretty tough because it was 5 steps. That's as bad as it gets. This next one actually quite a bit easier. This one says, how many joules of heat are required to change 5.0 grams of ice at 0 degrees Celsius into steam at 100 degrees Celsius? So we're starting here. Oh, by the way, I should say, I added this place here where it says at 0 degrees Celsius. I meant to have that in the original version, but I've added it now to this, so you should make that change to your sheet if it doesn't say it on there already. So what we've got here, we're going to start ice at 0 degrees Celsius. So it's on this side of 0 degrees Celsius because it's on the solid side. And then what we're going to do is melt it, and then we're going to heat it up to 100 degrees, and then we're going to boil it. And that's actually where we're stopping. We're stopping at steam at 100 degrees Celsius. So we're not heating up that steam at all. So this ends up being a 3-step problem. Step number 1 is melting. So we're going to have delta H equals m times heat of fusion, which equals 5.0 times 334, which equals 1,670 joules. Positive because this process is endothermic. Step number 2, we're going to take that water and heat it up from 0 degrees Celsius to 100 degrees Celsius. So Q equals mc delta T, which equals 5.0 times C for liquid water, 4.184, times the change in temperature, 100 degrees Celsius. Multiply all those out, we get 2,092 joules. Next step, we're going to boil it. So delta H equals m times heat of vaporization, which equals 5.0 times 2256, which equals 11,280. I'm going to take a moment here just to mention how heat of vaporization is so much higher than all these other values. That just goes to show, how strong the intermolecular forces are and how we have to overcome the intermolecular forces to such a high degree when we're boiling, because we take the liquid particles and we pull them completely apart into the gaseous particles. So that's why that heat of vaporization is often the largest step on here. Okay, so the next thing that we'll do is add them all up. We get Q total equals 15,042 joules. Okay, so now we have this challenge problem here at the end. It says if 2,000 joules of heat are added to 100 grams of ice at -5 degrees Celsius, how hot will it get? And what state of matter will it have? So in this one, what we're starting here with is ice at -5 degrees. And we know that we have 200,000 joules of heat to work with. And so what I'm going to do is just kind of go through the steps that we would have if we were heating up ice at -5 degrees and see when we run out of heat energy, of thermal energy. So the first thing I'll say is, like, what we do first is we'd heat the ice up from -5 to 0 degrees Celsius. So what we have is Q equals mc delta T. That is equal to 100, 0.0 grams times C, 2.060 for ice, times the change in temperature, just 5 degrees. Multiply all those out, we get 1,030 joules. So that takes hardly any of our energy at all, so we know that we can keep on going here. So after we heat it up, we'll melt it. So we have delta H equals m times heat of fusion. And we'll see how much energy it would take to melt the whole thing. So mass, again, 100.0. Heat of fusion, 334. We multiply those together. We get 33,400. Again, now we're in the range of 34,000, so nowhere near 200,000, so we're going to keep going. Step number 3, we're going to heat the water up. Okay, so Q equals mc delta T, this time for water. let's see how much energy it would take us to heat it all the way up to 100 degrees Celsius. So that would be 100.0 times 4.184 times 100 degrees, from 0 to 100 Celsius, I said. Multiplying those all together, I get 41,840. All right, so looking at this, if you add all those up, we still haven't gotten anywhere near 200,000 joules, so we're going to have to keep going. So now what we've done here, just as a recap, we've taken ice at -5, we heated it up to 0, then we melted it, then we took that liquid water and we heated that up to 100 degrees Celsius, and we're going to keep going because we haven't run out of energy yet. So for boiling delta H equals m times heat of vaporization, which equals 100.0 times 2256. If you multiply those together, you get 225,600 joules. Now notice here, the process of boiling alone is actually more than the entire 200,000 that we had been given originally. And so 200,000 joules isn't even enough to boil 100 grams of water completely. So if we had started at this step, we wouldn't be able to complete it. So we certainly don't have enough energy to get it done now. So at the end, we're going to be stuck here in the middle of step number 4, heating up and boiling it. If we're boiling it and we're in the middle of that process, it's going to be 100 degrees. So where we're at here is we're in the process of boiling. At 100 degrees Celsius. Because we don't have enough energy to get all the way through that. So that is that. If you have anything that's confusing you about this assignment, make sure you come in and ask.